Before we construct an alignment from memoization matrices, we need to create traceback matrices. So over here we have TP, TQ, and TD matrices, each of which correspond to P, Q, and D matrices. So what these traceback matrices essentially do is that they store information about where the value in each given cell came from. So for instance, for TP, the value could have come from two places. The upper row of D, which is when there was a gap insertion in sequence P, or the upper row of matrix P itself, so gap extension in B. Similarly, for TQ, the value could have come from the left column of D, meaning gap insertion in A, or the left column of matrix T, meaning gap extension in A. Lastly, we have matrix TD, and there are three options where the value could have come from. We have D diagonal, meaning that there is an alignment of two nucleotides without a gap. And over here, this is wrongly labeled substitution. It could be substitution or it may be a match. It could have come from matrix P, in which case we would have a gap on I and J, on J's nucleotide of B, or the value could have come from matrix Q, in which case we would have a gap in I's nucleotide of A. Now, I know this sounds it's a lot of information, so let's follow one example. And remember how we started filling out our matrix from this cell. And because we had infinities in the first row of matrix P, we took the value from the upper row of matrix D. Therefore, we would fill out this cell as D upper. Similarly, for TQ, because we had infinities in the left column, we had to take the value from the left column of matrix D. So, we would put the following information in this cell. Lastly, because we took the information for matrix D, we took the information from its diagonal cell, therefore we would put D diagonal. So this is pretty much how it works, and I will go ahead and fill out the rest of the matrix and we can start the traceback. The only thing left for us is to follow these traceback matrices and record each step. So I brought this tracker back from our previous video so that we can track the values of I and J, and we will start from the value of I equals to 2 and J equals to 4 in matrix TD. So this corresponds to a cell highlighted right here. The cell contains the information that we need to refer to the matrix TQ. The corresponding cell in matrix TQ is this one. And whenever we have Q left, this meant that there was a gap in A. And we are going to put a gap in alignment A and align nucleotide T from sequence B. Now, this cell is telling us to go left, and we will do this by decreasing J. So we completed this step, and now we are looking at I equals to 2 and J equals to 3, which corresponds to this cell right here. This cell also contains the information that there is a gap in D. A gap in A. So again, we put another gap and we put a corresponding nucleotide. So we are picking these nucleotides from right here, the nucleotides that are in the same column. Now, similarly, because we have a left arrow right here, we will move to the next column by decreasing J. So we've completed this one here, and right now we will be looking at I equals to 2 and J equals to 2. But instead of continuing with TQ, we will move back to the matrix TD, because the previous cell was referencing to the matrix D. So right now we are looking at this cell, which contains the information that there was that there is no gap because we have D diagonal, which means we can take nucleotides from the corresponding row and column and put it here. Now we've completed another set of I and J values, and because it's a diagonal, we need to move diagonally by decreasing both I and J. So we will be looking at I equals to 1 and J equals to 1 in matrix D, because this is taking the values from within the matrix. And as I highlighted, we are looking at this cell at I equals to 1 and J equals to 1, and again this contains the information that there was no gap. So we are going to take corresponding nucleotides from the same row and column and put it right here. In the next step, we are moving diagonally again. So we've completed here and we're right here. And this is because both I and J are equal to 0, it means we have completed our alignment. So this is the output. But remember that we started alignment from the very last cell over here. This means that the alignment we're looking at now is reverted. Therefore, in order to get the final alignment, we need to reverse. So the output would be AC gap ACCT. So this is essentially just the same alignment read backwards. And we have completed our alignment. And this is the essence of the Gotoh's alignment algorithm. In the next video, we'll talk about what exactly the profile aligner does and how it is different from the Gotoh's alignment algorithm.